Hello grade 11. So the next example I want us to take a look at is how to use the refractive index calculation. So we can use the example that they set forth here, and they say use the value given in table 5.1. Now the notes that I sent out to you guys, you will see that it's the table of refractive indexes. Please, you guys don't need to remember that. If I expect you to work with refractive indexes, I will give you the value. The only refractive index value you need to remember is the refractive index of air, which is 1. Okay, so they tell us use the value given in table 5.1 and the definition of refractive index to calculate the speed of light in water. So the refractive index in water is equal to 1,31. Okay, so we have the refractive index. Then they also tell us that we have to calculate the speed of light in water. The speed of light as a universal constant is 3 times 10 to the power of 8 meters per second, and that will always be given to you on your data table. So now we can use the refractive index calculation that tells us that the refractive index is equal to the speed of light in a vacuum divided by the speed of light in that material. That means for all purposes, the velocity of our actual light in water will be equal to the speed of light in a vacuum divided by the refractive index, because we're multiplying the velocity here, dividing the velocity here, we're going to multiply on that side, and then because we're multiplying with our refractive index, we're going to be dividing on the opposite side. So here, to get rid of this one, we're going to multiply by v and multiply by v so that they can cancel. Well, we're going to be multiplying here by v over 1 and there by v over 1 so that they can cancel out, but then that side we're also multiplying by n. That's why we're dividing by n on this side. So that we can go on, we can substitute in our values. So we have 3 times 10 to the power of 8 meters per second divided by the refractive index, which is 1,31. And now we can calculate this value. So we can simply go and we can say that is 3 times 10 to the power of 8, the speed of light in a vacuum, divided by the refractive index in ice, so 1.31, and that gives us then 2,29 times 10 to the power of 8 meters per second, and there we've calculated the speed of light. The same thing would apply if, for instance, I had to go calculate the actual refractive index. Because C is a constant value and you always know the value for C, you would have just used the initial formula and said it's the speed of light in a vacuum, that's 3 times 10 to the power of 8 divided by the velocity in that specific material, and that gives you the refractive index. Remember, refractive index does not have a unit.